In this video, we will discuss a few more indeterminate forms. The first one is infinity minus infinity, right? This is an indeterminate difference, right? So by the notation, we should be able to decide this is basically as x goes to a difference of two functions, f of x minus g of x, such that what happens is as x goes to a, f of x goes to infinity, g of x also goes to infinity, right? Cannot be negative infinity because infinity plus infinity minus negative infinity will give you infinity plus infinity, which is infinity. So only positive infinity minus positive infinity, or negative infinity minus negative infinity are undetermined. So uh, we have to we have to do something to decide what is this limit, right? Is it limit finite number or or infinity or zero, right? Okay, so let's see examples, right? So remember, we have only one way to handle this kind of limit L'Hopital's rule, which handle quotient. So whenever you are given an example, for example, this, right? This is cotangent of x minus 1x. And this is basically uh, because as x goes 0 on the right side, cotangent of x goes to infinity. 1x also goes to infinity, right? This is basically infinity minus infinity. So we can only handle quotient or using L'Hopital's rule, right? So only way is follow some using some algebra, change your function to a quotient form, which is either 0 over 0 or infinity over infinity. Then you apply the L'Hopital's rule. So quotient, how do we do that? We don't have many tricks in this example. First, we don't like cotangent, right? Change to cosine of x over sine of x minus 1 over x. Then second, take a common denominator, right? That will work. So this is x times sine of x, x times cosine of x minus sine of x, right? Now you can see that as x goes 0 on the right side, x times sine of x goes to 0, x cosine of x minus sine of x also goes 0, right? So this is 0 over 0. We are ready to use our L'Hopital rule. So this is as x goes 0 on the right side, cosine of x. Here, for the first term, you have to use product rule, right? Then plus x times negative sine of x, then minus cosine of x over sine of x, plus x times cosine of x, right? And try to simplify this because cosine of x cancel each other, right? You get an easier fraction. So this is equal to, as x goes 0 on the right side, you get negative x sine of x over sine of x plus x cosine of x. Plug in 0, still have 0 over 0, right? Try to differentiate one more time. X goes 0 on the right side. You get negative sine of x, then plus x cosine of x over cosine of x plus cosine of x plus x times negative sine of x, right? Now you can see that as x goes 0, the numerator still goes 0, sum of 0, 0, and denominator goes to 2, right? So this is negative 0 over 2, so this is 0. So this is how do we handle indeterminate difference. Our only way here is change from a difference to a quotient, then apply L'Hopital's rule. Sometime maybe twice, 3 times is possible. Eventually, you get a finite number. If you cannot get a finite number, then this approach fails. Try a different one, right? So this is our way to handle indeterminate difference.